Okay, hi students. Okay, let us in this video we will again see one more problem, how to find the value of k for a given specification. So in the previous video we have seen two specifications where the value of k is determined for a given gain margin and a given phase margin. So let us now try to find out how to determine the value of k when omega gc is specified. Okay, these are the prerequisites. Okay, afterwards let me just go here. So in the previous problem, as we know that we actually did it for this transfer function. We had the first condition where the gain margin was specified as 15 dB. We found the value of k using plot which comes out to be 8.91, and then we actually found for the same transfer function for a phase margin of 60 degree, we found the value of k is coming out to be 0.5 using the plot. So this is the result of the previous video. Now let us consider the same transfer function and let us find the value of k such that the omega gc is maybe around 12 radian per second. With omega gc as 12 radian per second, we are asked to find what is the value of k. So now let me just rewrite that. So now this is gfs into hfs. This is gfs into hfs, which is nothing but k divided by s into 1 plus s 1 plus 0.02 s is the transfer function. What is k for a omega gc of 12 radian per second? Again, what is the procedure? With k equal to 1, plot the Bode plot, find what is omega gc, and then you shift the 0 dB line such that omega gc is equal to 12 radian per second. You see the amount of shift. So 20 log k will be equal to amount of shift in 0 dB line. So that, let me just do this problem and then try to find out. So let me just take the same plot which we already plotted. So forget about this new 0 dB line, this one. So this is done for a phase margin of 60 dB. We shift to the new 0 dB line. So now this is the virgin plot for k by s into 1 plus s and 1 plus 0.02 s. So we actually took k is equal to 1. By taking k as 1, this is the plot. So if you can carefully notice, this is 0 dB line, this is omega gc. So how much is omega gc? Is actually 1 radian per second. What is now asked? What is asked is, we are supposed to find out what is the value of k so that omega gc is 12 radian per second. So where is 12 radian per second? You can see on this plot, this is actually 10. So we know that this is 20. So 12 happens to be 2 divisions from here. So is it actually now here? This is actually 12 dB. So sorry, 12 radian per second. This is actually 12 radian per second. Now the 0 dB has to shift from here to here. So now I'm going to shift it down here. Can you see now this is 0 dB line? It is somewhere in between. Okay, just make to move here. So this is new 0 dB line for omega gc of 12 radian per second. We actually plotted this green colored plot for k equal to 1. We plotted this, then we got some omega gc, and forget about that. what is asked? We are asked to find the value of k such that omega gc is 12 radian per second. No, this is actually, we are trying to identify where is 12 radian per second. So this is 12. So now the 0 dB has to shift here. Now this is 0 now. So if this becomes 0, then how much is this now? So actually how much you came down from here? With this as 0, this is 20. With this as 0, this is 20. So what is magnitude at origin now? Magnitude at origin is actually, as per this equation, it's actually 20 log 1 minus 20 log 0.1 for this, that is for this 1 and s. Because this 1 was 0, 1 was 20 log of 1 is 0, so this becomes 20 log of 0.1 becomes minus 20. Since it is minus of this, it was coming as 20 dB. So that's what is this. Now when I shift this 0 dB line, so what is now 0 dB line? 0 dB line has shifted now. So what is magnitude at origin? How much is the amount of shift? You can see it is 10, 20, 30, 40, 43 dB it came down. So 0 dB has shifted by 43 dB down, 43 dB is down. So then does this 20 becomes 20 plus 43, which happens to be 63 dB. So now this is now 63 dB is equal to 20 log, it's no more k, now it is not 1, it is k. What is the k now? The condition is omega gc is equal to 12 radian per second minus of 20 log 0.1. So how much is the value of k now? I can find 63 alpha equals 20 log alpha a minus 20 log 0.1. Shift cal, you get the value of k. K value comes out to be 141. So k is equal to 141.2, not radian per second, this is the value. So with k equal to 1, omega gc was 1 radian per second. With k is equal to 141.2, the omega gc will be 12 radian per second. This is the requirement. So the answer for this is okay, what we did, we actually plotted the thing here. So what is this 20 log k is equal to? What is the amount of shift? Amount of shift is, how much is the shift here? Can you see how much is the shift? You have shifted this down by 43 dB. So this 20 log k is equal to 43. So then what is k? K is equal to, of course both are same. So the way, if you do by this way, you'll get same value of 141.2. If you do this way, the amount of shift, you also get the same value. So it is 10 to the power of 43 by 20. How much is this? 10 to the power of 43 by 20. Okay, sorry, it is 10 to the power of 43 by 20. Can you see it is 141.2? Here it is exactly same. 141.2 is the value of k, which we actually got it from this also. So here so the procedure is, you plotted the graph with k equal to 1 and we got omega gc as 1. Now I have to shift the 0 dB line to a new point which corresponds to omega gc of 12. So now when you're shifting this by 43 dB, how much will be the shift of this? So this 20 will become 20 plus 43, this is 63 dB. So once it becomes 63 dB, then you can use this equation. Magnitude at origin is nothing but 63 dB, 20 log of k minus 20 log of so and so. You get the value of k as 141. So I did use this equation also, which is 100% true or correct. So 20 log k is nothing but amount of shift that you have done. If you are shifting it down, does this increase? So that's why it is 20 log k is equal to 43 dB. So this is actually 43 dB. So then if you know this 20 log k is equal to 43 dB, then how to find the value of k? It is 10 to the power of 43 by 20, which is 140. So this way you can usually find the value of k for a given omega gc, given gain crossover frequency. So these are the three different ways of three different categories where you can find the value of k for a given gain margin, given phase margin, given omega gc. So this is the thing. Thank you.